passion and one that has led to some very significant technologies. And it gives me really enormous pleasure to introduce him to you today. James Dyson.
Thank you very much. Thank you. I want to talk to you today about my particular passion for mixing engineering and design. Design in the past has been treated as to how something looks. In other words, styling. I think that's rather an old-fashioned concept. I think design is about the technology in a product, how it's engineered, how you use it, and of course how it looks and what it's like to use. So I'll jump straight in to my first slide and talk about some of the influences I've had. And Isigonis, that rather shy man behind the car there, designed and engineered the Mini. So he did both functions. And the sketch on the right was done in 1958. And a great friend of mine was with him in Cannes, sipping gin and tonic on a balcony overlooking the sea. And he drew this drawing of the Mini. And it's interesting because, not only has he drawn what the car's going to look like, the body, it's 10 feet long, and it's supposed to carry 4 adults and lots of baggage, and I'll show you a little section in a minute of that. But he put a transverse engine across the front here, with a gearbox driving the front wheels. And that was a complete innovation. It hadn't been done before. And he also did a rubber suspension unit here. But the most innovative thing probably were the small wheels. And he wanted to have small wheels because small wheels meant that you didn't have this horrible wheel arch going into the interior of the car, which took up so much space. You're probably not very familiar with that on modern cars, but old-fashioned cars were dominated by this enormous wheel arch coming into the interior of the body. But the trouble with small wheels, there were 2 problems with small wheels. One was they thought the rolling resistance was higher for a small wheel. But they made a discovery that, in fact, if you pumped the tyres up harder, they had the same rolling resistance as larger wheels, so that was great. And the other problem was the suspension rate of smaller wheels, and they solved that by having rubber suspension rather than coil springs or leaf springs. And if I go on to the next slide. So here's how he did it. So he had this transverse engine driving the front wheels, this huge interior, not dominated by wheel arches, and there's the luggage in the back. And all along the side here, which you'll see on the next slide, here. It's a very simple dashboard. There's no door handle. To open the door, you pull a cord down, and sliding windows, which means that the exterior of the car, this is actually the exterior of the car. There's no panel there at all. And there's this huge compartment here. And he turned up at my friend's house. This is the friend who sat on the balcony at Cannes with him. And he had this, he said, come look at this. And he had this thing here, completely full of Gordon's gin. So there's a connection, you see, between designing, sipping gin. And I rather like this. They made a big fuss when they launched it about the testing they'd done. Well, testing is now commonplace in cars, and they go all over the world to test things. But this is probably one of the first times it was done. And this was done in the Alps. And I think what's rather amusing is it's slightly reminiscent of the Italian job, which is, of course, the film later made of it.
I've been able to live now for almost a half century on the frontier.
I'd like just to listen to this.
Without anybody guaranteeing me anything or telling me what to do. I've learned how to survive there, and one of the things I do is never to try to persuade anybody to. You don't try to sell anything. You see what needs to be done and you do it.
Pretty good advice, that. But I like Buckminster Fuller because he was a great inventor, he was a great designer, he was a great architect, a great engineer, and of course he's famous for these wonderful light eggshell roof structures, replacing previous much heavier sections. And he was, of course, a very green designer. Probably the first green designer, using far fewer materials and having his Dymax in-house rotating to face the sun. But he just got on and did things, as he said. He didn't bother to sell them, he just did them. And so that my 2 heroes, if you like, when I was at college were these 2 people who were great designers, revolutionary designers, engineers and inventors rolled into one. And although I was training as a designer, I took off at the end of my design course and went to work for an engineering company to learn engineering and R&D. And this is one of the first projects I worked on. Now, I went water skiing with another friend, and we were pulling his daughter behind the boat. And we noticed that, I mean, you would think that flash man there is going much faster than this man with whom you have much more sympathy. In fact, he's going a lot faster than he is. And that's what we noticed, and we were surprised, because we thought that the monoskier would go much better than the two skis. So we then took we had a huge motor cover on the boat, which is a large 8x4 sheet of plywood, and we put his daughter on that and towed her, and she went even faster. And this seems slightly counterintuitive, but what we then looked it up in a book and found that this is it's all done in feet, it's quite an old thing, but this is the width of hull that you need for the load you're carrying. So a person is 180 pounds, 170 pounds, and you need a 2-foot, the ideal planing hull for that weight is something 2 foot wide. Of course, a monoski is much less. 2 skis gets you to about that, but you ski that wide, 2 foot wide, about that wide. And it gave us an idea for doing a boat that was like a truck that went on the water. I think here we are. And that's the boat we developed, which is really a huge flat sheet of plywood. It's actually made of fiberglass, but in essence, it's a huge flat sheet with skegs along the side, which you can see just up there. It has side skegs. That's rather a bad illustration, actually. They're much smaller than that. But it traps bubbles underneath the hull as it planes. And because it's trapping bubbles underneath it, it removes the frictional resistance. In ship design, you have two problems. You have wave-making drag at sub-planing speeds. And then once you're up and planing, your wave-making drag goes, and you have frictional resistance. If you trap bubbles underneath like that, you enormously reduce the frictional resistance. So our boat was able to go very fast. And so if you look at the top here, it went fast because it was getting all the pressure from the water, all the effect, whereas the V-hull dissipates it. So a V-hull is not a very efficient planing hull. It's very stable because it's wide and flat. We happened to put foam inside, so it was unsinkable. And then it had very shallow draft, of course, because it's flat, whereas the V-hull obviously draws much more water, so it could land right on the beach, as you saw the soldiers doing there. And then it has this very practical rectangle, which is very good for loading a jeep, or even 2 jeeps on it. And it would go, to give you an idea, it would go about 60 miles an hour, and with soldiers on it. With a couple of jeeps, it would do about 45 miles an hour, which is very fast for a boat, and with relatively small engines. We then had the problem of selling it. People described it as a Welsh dresser on water, because it just didn't look like a boat. And in fact, the first one I sold was this one for building the Bosporus Bridge in Turkey. And then we sold one on the Royal Yacht. So the Queen had a red carpet which rolled down onto the beach so she could walk off. This one, I supplied several, actually, to the Egyptian Special Boat Squadron. And I was out there, I took this photo, and they had a Russian jeep, and we had wheels that clamped on the side so you could tow it across the land. And I was out there doing speed trials, and they wanted to mount what sounded like a huge cannon on the side of the boat. They didn't tell me what it was, but they told me what it weighed. So we had to make the boat go as fast as possible with this particular weight on it. I left, and about 2 weeks later, they stormed Sinai and used a cannon to spray ciment prompt, which is a quick-setting French cement, over the napalm outlets that the Israelis had down the Gulf of Sinai. And then the troops followed, and they achieved quite a remarkable victory, actually. No one thought they could get into Sinai, but they did, and I'm afraid it's our boats that did it. But when I'm not partisan in this, we also supplied the Israelis with quite a lot of boats. We did get into trouble about that, but anyway. There it is with 2 Land Rovers going to about 45 miles an hour. Now, I'd used a wheelbarrow at home because I'd bought a house and I was doing it up. And I noticed that the wheel was terribly narrow and used to sink into the soft ground. and the feet of the wheelbarrow used to, you know, you'd load it up and the feet would sink in and the thing would tip over. And the nasty metal bin would